So once again, we have our expression here that predicts where the bright fringes appear. And the question we need to ask ourselves is anything changing when we take our double slit experiment and immerse it in water? Well, we wouldn't expect the distances to change. So the separation distance of the slits, the distance from the slits to the screen, those things are not going to change. And the m values will m equals 0 is still going to be the center of the pattern, and then m equals 1 and minus 1 give us the bright spots on either side. But there is one thing that is going to change, and that's the wavelength of the light. We know that when we have a different index of refraction material, that the wavelength of the light in that material changes. So if we immerse everything in water, we would expect the wavelength to change. So the next question then is, how is it going to change? And we remember that we had this expression, n1 lambda 1 is equal to n2 lambda 2. So if n1 is air, so if the whole thing was carried out in air, we have one wavelength. n2 is water, and so we're going from 1 to 1.33. n2 is getting bigger, so the wavelength is going to get smaller. So if we increase the index of refraction, we're going to be decreasing the wavelength so that this remains equal. So if the wavelength is getting smaller, then the distance to each bright fringe is going to get smaller, and the bright fringes are going to move closer together.